Hello, my name's Cole, and this is my walkthrough of my market anomaly detection project. So, the scenario is market crashes do happen, and the market's worst days have a big impact on investment returns. On the right, you can see that if you can detect and miss the 10 worst days, you can triple your returns. So the goal is to develop an early warning system able to detect these anomalies to inform investors, and starts with training and testing a classification model based on a data set to classify if a day will be anomalous or not, or a day or week. So here's a quick glance at the data set we were provided. This is like showing all the anomalous weeks from the 2000s to um, 2021 and all the financial indicators. I don't know why it's bugging out, but yeah. So just diving into the code I did, let me scroll to the top. So first you gotta explore your data so you can get a better feel of like which features are more important or not. So up or uploaded a CSV file, got a little glimpse of the shape of the data I'm working with. See here, there's no null values I have to worry about in pre-processing. More statistics, a little class distribution, working with an imbalanced data set. Um, some more graphs here, feature distribution. So with these, you can like, if the curves are more distinct between crashes and no crashes, they have more predictive um, ability. So you can see with that, the gold here, also the VIX indicator. So here you can also do correlation analysis. I grabbed the top 10 features correlated with Y, and I plotted them. I listed them and plotted them here, with one being like a lot of positive correlation and negative one being negative correlation. Yeah. So did some more box plots to see the difference in the means for these different features, all just giving me a better idea of like which features are more important. So next up was preparing the data. Um, I grabbed the top 10 features based on that, and I did some experimentation to find the best like combination of features that were garnering the best results. And you can see that here. But what I found through more testing was that if I just pass in all of the columns as explanatory variables, it garnered better results. So yeah, that's what I did uh, in the end. So sure, split it into training and test sets with test size of zero point 0.5. And originally I had shuffle false so that the data set would be processed sequentially. So I thought that was important, but it actually, when I removed it, it increased my model's accuracy and recall. Did some scaling here for training and testing the first model, which was logistic regression. So yeah, you can see that here, trained it on the set, how to make predictions. Then I visualized the accuracy of the prediction. So you can see there's a lot of false positives and few false negatives, and didn't really have the best results when classifying crashes. So you had to experiment for better results. So I started off with exploring different models. So use some ensemble models here that are better, that work better with imbalanced data set. Um, Random forest got pretty good results when classifying crashes. Isolation forest, subpar. XG boost got even better results in random forest. So those are my two contenders that I mainly focused on. For this, another way to can improve results is tuning the classification threshold. So I found that zero point 0.3 was the best for random forest. Um, so yeah, did that. Then I tried messing with the with SMOT, synthetic minority oversampling technique, which is used to balance out data sets, but found that didn't really have the best impact on results. And lastly, I did some hyperparameter tuning using Optuna to try find the most optimal hyperparameters, which were here, the results. But um, I tested it out, and it resulted in my XG boost. I switched to XG boost because I saw that someone else got really good metrics with them, so I just switched there. And but the optimal hyperparameters weren't really optimal, so through more experimentation and manually optimizing, I was able to get it to have an F1 score of classifying crashes at 0.78. And going into the results, yeah, using the XGBoost model with fine tuning, I was able to achieve the F1 score of 0.78, which is pretty impressive to a novice like me. And if we were to detect 8 out of 10 worst days, leads to 2.72 times the average return, which is very helpful. And how I would expand on this project would be to set up a system that would grab real-time data, ensuring data standardization with my data set, and with that propose data-driven investment strategies. Yeah, focusing on minimizing losses and maximizing return. But thank you for watching my presentation.